1622 is a time value of money application, which is stuff that we've already kind of touched on in other chapters, so I'll run through this very quickly. In requirement A, Spencer Company has this common stock. Now, it doesn't really matter how much common stock you have, but because it's been identified to have a dividend of $5 per year on that stock. Okay. And then each one of the stocks then has a market value per share that will be definitive in 10 years at 124. So what we're going to do is we're going to try to find, guys, what this stock is worth right now per stock. So if we do that, we're going to use what is considered the market rate. Now, understand that in this problem, what's the maximum price that an investor would be willing to pay for it was only if it had an investment of 12%. So use 12% as your market rate then, okay? If that's what you need in order to justify this investment in stock. So if you take that dividend per year, remember that's the amount of money coming from that stock each year. And so we then go to 6.5, the annuity table. And we're going 10 periods here at 12%. So we get this factor. Now, you can also use your financial calculators for this, guy. It's fine. And then you bring this amount over here, and then we go over to the amount that this stock is going to be worth at the end of 10 periods. And it's going to be a factor of 3220 from table 6.4. And we bring it over here, and we just add the two together. So that's the maximum amount that you would want to pay for the stock. It's really what it's doing, guys, is it's calculating a present value of the stock. And so we've done this before back with bonds. And as a matter of fact, requirement B here is, in fact, a bond where an individual, Mario, owns a bond. Okay. And 5 years on that bond has already gone by. Take notice of that. So your periods is 5 periods, and we're going to get a draw interest of $80 a year on this, which that means it's our annuity. So I'm going to take our annuity here, and I'm going to divide it by a factor from table 6.5 based on 5 periods and 10%. And I'm going to put it over here. And then I'm going to take the maturity value. This bond is going to be worth the face amount, right? It's $1,000 in 5 years. So we're going to take that and get a present value on it, and we'll just kind of add those two together. Well, that's the market value today of this particular bond, which is what you had wanted to calculate, right, in requirement B. So those are kind of fun, guys. You want to do a few of those, kind of get used to them. So punching them into the calculator or however you input that into Connect. But C is a little bit different. Whereas you buy savings bonds for a certain amount, like $100, and it's going to be worth this amount in 8 years. So you're trying to figure out, like, what's your interest rate on that? Well, if you take those two numbers that they gave us here, and these are shaded down here, right here, and you kind of divide the maturity one into what you paid for it, then you're going to get a factor. Yes, and that factor you can apply to table 6.4, because remember now that is a fixed amount, a value in the future. So this is not an annuity. So we go to the present value of one table, and we would apply this 0.6274 in the 8 period row, and we would find that we are going to draw 6% on this particular investment of a savings bond, Series EE savings bond. Okay. Now, I'm going to skip down here to 1625. And this is a similar problem, but there's a little bit of a twist to it, a little bit of a difference. We can use these same kind of calculations if we have an investment, right, that we're trying to make into a piece of machinery or maybe even a project, if you will. and we're going to dump a bunch of money into this particular investment, and that investment is going to give us returns. Okay? And those returns we want to kind of analyze as to contrast, if you will, against the investment amount itself, so that we can kind of decide whether, whether or not this is a good investment or not. So let's look at these numbers. We got a machine here that we could invest say $85,000 into, and we expect that machine to give us a annual cash flow of about 14,000. And then at the end of 8 years, it's going to be worth about 9,000. So we can kind of consider that to be sort of a maturity value amount, okay, like a amount in the future that it's going to be worth. So the 14,000 would be your annuity. That's the amount of money you're going to get each year. And so if we take this amount, 14,000, and divide it by a factor from table 6.5 of 8 periods and 10%, we can bring that amount, that's the future present value of that $14,000 cash flow, turns into 74,689. We take the present value of this 9,000 salvage value, dividing it by the factor from table 6.4, 8 periods, 10%, and we bring it over here. And then remember, these two numbers in blue here that we calculated using the tables and factors from the tables, then we are comparing these two numbers to the 85,000. So if you add these two together and you contrast out this 85,000, then you have a negative net present value of $6,113. Now remember that we have used the cost of capital in here of 10%. And I want y'all to know that the cost of capital is something that's just kind of determined by management to be an amount that we need to make on an investment in order to kind of cover, our expectations for a return on that investment. So in this case, a 10% cost of capital is a good modest rate that we expect to make on any kind of investment we're making. So we need to make 10% on it, in other words, and that's why we're using 10% here to kind of see whether or not the returns that are expected from this investment are in fact going to be, as compared to the investment itself, what's going to be the difference here? Okay, what kind of return are we going to get? So a net present value, guys, that's negative means that our internal rate of return is going to be lower than cost of capital. So our rate of return on this investment is lower than the cost of capital. So it might have a negative effect on our decision to invest in this piece of equipment or not. So I do encourage you guys to go into the chapter and to really read up on cost of capital, and then read up on internal rate of return, and then read up on this kind of calculation. They have a really nice big simulation in the chapter of one of these problems, one of these investment in a project problems, which we're going to do next. But we're going to do another one of these, and we can take a close look at it and see, how they come up with either a positive or a negative, and they have a little table that shows you whether or not that's a good thing or a bad thing, depending on what you set your cost of capital amount to be. So it's interesting to check into that.